Okay, now I'm going to be going through some of these questions from the WJEC past papers on C1 on binomial series, but I've also found a couple of questions from a different exam board just to have a few unseen questions and try and show you how to do them. Okay, so before any of these questions, I'd recommend that you pause the video and that you've had a good go at this yourself. Okay, now the first question is very simple, from C1 Jan 2009, and just turn the light on there, and it says expand a plus b to the power of 5. Now, whenever you're given the power here, I would recommend using Pascal's triangle unless it's a very big number. Okay, if it's a big number, you're going to have to come up to the formula booklet or come over to the second page of the formula booklet and try and work out how to use this. But we have looked how to use this in class, and it tells you here for n over 2, where NCR is this thing here, and it shows you exactly how to work this out. Okay, so you should know how to use it anyway, but for me, I find Pascal's is quite quick in comparison. So, because it's to the power of 5, I'm looking for the row where the second number is a 5. So if I just generate that very, very quickly, you should be very quick at doing this now. You should see the pattern there. So then for the fifth row, it would be 1, 5, 10, 10, then 5, then 1 again. So what we looked at before for part A is that it is going to be that coefficient there, and then I'm just going to put in all the coefficients like this straight away. And the key thing to doing binomial really, really successfully is that you space your working out. If you try and jam it all together really, really quickly, you're probably going to make a mistake somewhere. Okay, so I've got my coefficients written out that I've just taken from there. They're coming there, but I've gone over 2 lines so I don't cram my work up. And then it's that first number, or first letter in this case, that goes there to the power of 5, because it's a power of 5 out there. And then it's the second letter, but to the power of 0. These two numbers must add up to whatever that one is there. Okay. Now you start off with the first number with its power, and that is going to descend by 1 each time. It's going to reduce by a power each time, and this one's going to rise by a power each time. So this time I'm going to get a to the power of 4 and b to the power of 1. This time I'm going to get a cubed b squared, and this time I'm going to get a squared b cubed, and then this time a to the power of 1 and b to the power of 4, and then finally a to the power of 0 and then b to the power of 5. Okay, now in some respects I didn't need to write a couple of these things in. In some respects a coefficient of 1 times something by 1, it's just going to remain the same anyway, so I didn't really need to write that in. I definitely didn't really need to write in b to the power of 0, because anything to the power of 0 is always 1. So truth be told, I didn't really need to write either of those bits here. So I could have said just straight a to the power of 5. This is an equal, sorry. Then this one here, b to the power of 1, I didn't need to write in power of 1. We know anything to the power of 1 is itself. So I could have just got away with saying 5a to the power of 4b. Then plus, now all of these are important. 10a cubed b squared, yeah, that all needs to be there. So a cubed b squared plus 10a squared b cubed. Then really didn't need to write in that power of 1 again. So I could have just said 5ab to the power of 4. And then finally, I could have just written b to the power of 5. Okay, now that part there, I'm sure it's going to help us in the next part. In fact, it even tells us, it says, use your answer in part A to find the coefficient of x cubed in the expansion of this thing here. Now, what we need to do, we need to try and match this thing up to what this thing here is. Okay, so I can see they're both to the power of 5, and I can see for part B, I'm going to say let A equal 1/4, because that's what's the front of that bracket, that's what's the front of that bracket. And I'm going to let B equal 2x. Now I'm looking for the x cubed, or the coefficient of the x cubed here. So that means I want the one where B is going to be cubed. So that is this term here. I'm not subbing into the rest of it, it's a waste of time, I'm not asked to do that, okay? So to do that, I want to do 10 brackets, 1/4 squared, brackets, 2x to the power of 3. And I just checked my work then very carefully. I wrote 2x, I thought I'd better check back here. If that was a minus 2x there, it would have to be minus 2x there. And then finally, by here, 1/4 squared, I'm going to write this in 2 stages, is 1/16, and then 2x cubed is 8x cubed. Make sure you cube the 2 as well, very easy to forget to do that. And then how many times does 8 go into 16? when it goes in twice, so I'm going to cancel both of them out there, but write 2 down in the denominator. And then 10 and 2 goes into 10 5 times. So my answer is 5x cubed. Okay? Okay, over the page. This question here, you've got to be really, really careful with. You really do need to take your time. As you can see, I've kept the formula booklet at the top of every one of these answers. You may need it, you may not. Whenever you're given the power, you do not need to worry about using this. However, if you are not given the power, like in this part B, then you need to come and use either this one or this one. Okay, so for part A, it says about the power being 4. So going back to Pascal's triangle on the previous page, you should know that that line is 1, 4, 6, 4, 1. So when I start to expand that thing, I'm going to do my coefficients first. And like I said, space it out. It will make your life easier. Okay? I'm then going to put this as x to the power of 4. I'm not going to bother putting 2 over x to the power of 0 because I know that goes to 1. Anything to the power of 0 goes to 1. But I will need to put it in the next step, which will be 2 over x to the power of 1. This would then be x squared, then 2 over x squared. Then this would be x over 2 over x cubed. And then finally this would just be 2 over x to the power of 4. Okay, so the first term of that is x to the power of 4. Now the next term of this is going to be 4 times 2. 2 to the power of 1 is 2, and then times it by 4 is 8. And then it's going to be plus 8x cubed over x. Now some people like to cancel down straight away. I'm going to wait and do another line. If you want to, feel free to cancel down straight away, but if you want to wait, that's fine. It really doesn't matter. And then I'm going to have, okay, now be careful here. It's 2 squared, which is 4, times that by 6, which is 24, x squared from there, and it's going to be over x squared there. So you may already notice that those two things are going to cancel, but like I said, I'm going to wait for a minute, and then I'll do it after. 2 cubed, that is 8. 8 times 4 is 32. 32x over x cubed. And then finally, the last one, 2 to the power of 4 is 16, and then over x to the power of 4. Now, out of these 4 marks here, I will definitely lose one because I haven't done what it said. It says simplifying each term. Okay, so now I need to do my simplifying. So I'm going to get x to the power of 4 plus 8x squared. Remember, you subtract the powers. This has really got the power of 1. 3 minus 1 is 2. Plus, now this is going to be just 24 because it's x squared. They cancel. This one here then would become, now you could write this in 2 ways. I'm going to write it as 32 over x squared, but you could have said that was 32x to the power of minus 2. That would be absolutely fine. And then finally, I'm going to have 16 over x to the power of 4. And what you should notice is these powers descend actually by 2. Look, 4, 2, x to the 0, really, if you think about it, then over 2 over 4. And that was because we had an x here and then an over x here. That's why it's done that. Normally, they just descend by 1 each time. Okay then, part B. Now part B says the coefficient of x squared in the expansion of 1 plus x to the n is 55. Given that n is a positive integer, find the value of n. Now this is when you have to use the formula booklets. And you either want to use this one here or even better, this one here. This one is incredibly simple to use. However, we can only use that if it looks similar, if not identical to what we've got. Now in our case, it says 1 plus x to the n. That is exactly what we have here. It says the coefficient of x squared. So I'm looking for the one with the x squared in here. There it is. I'm interested in this bit here. Now be very, very careful. This 1.2 is not 1.2. It is not that. 1.2 means 1 times 2. Okay, that's what it really means. Dot notation is like a shorthand way of writing multiplying. I've never been a fan of it myself personally, but that's what it means. Okay. Now when I'm talking about the coefficient, I'm not talking about the x squared, I'm talking about the number in front of it. So that's why I've only highlighted this bit here. So to find out that coefficient, I know it's n brackets n minus 1 over 1 times 2, which is just 2. So I'm going to write it as n is just over 2. And I know it's equal to 55 because they told me in the question that the coefficient of the x squared thing was 55. I'm now going to just solve this and get n on its own. The first thing I'm going to do is expand the bracket to get n squared minus n. And at the same time, I'm going to bring this over 2 round and times by 2 to get 110. And then I'm going to have n squared minus n minus 110 equals 0. Now you should be looking at that and thinking, oh, I don't know what two numbers times 210 and make -1 are. It doesn't look like it's obvious, but if it ends in a 0, think about the obvious numbers that time together to make that, and for me, you should know that it's 11 times 10. Now that's good because that's a minus, and then that means one of these will have to be minus. Minus 11 times by 10 is minus 110, and then if you do a minus 11 add 10, you get -1, which is that coefficient there. Perfect, that's our combination. So we're going to have n minus 11 and n plus 10 equals 0. So n is equal to 11 or n is equal to -10. If you go and read back the question, it will tell you which one it is. It says given that n is a positive integer. So that means my answer is that. So make sure you highlight the one that you're choosing. Okay? Okay, next question. Back to one like we just had, where we don't know what the power is. If we don't know what the power is, then we must use either that one there or there. Now, at first glance, you'd look at that and say we can't use that one there, but this is the easiest one to use out of the two. I can't use that one because x isn't x, it's 2x. But this is very easily rectified. We say let x equal 2x. Okay, the 1 plus bit is still the same. Brilliant. That means we can do it. Okay, so I'm going to have 4. Now, what's it say in the question? It says the coefficient of x squared is twice the coefficient of x. So the coefficient of x is just the n. The coefficient of x squared is this bit again. Okay, so I'm going to write down coefficient or coef of x is equal to n. Coefficient or coef of x squared is equal to, now we have to be very, very careful with this. I just realised a small mistake I've done here. I need to include the x squared bit because x isn't x in this case. I'm making x equal to 2x. So if I write down the whole thing for there, that's nx. Here, I'm going to have n minus 1 over 1 times 2, but that's not really x squared in this part because I'm letting x equal 2x. So I'm going to put brackets 2x squared in there. Okay? So if I now deal with those coefficients, the coefficient of this still is just the n, whereas this one now I need to expand it. I'm going to get n squared minus n, brackets, and then I'm going to have 4x squared from when I square that term, and that's going to be over 2. That 2 goes into the 4 twice, so that is then going to be 2n squared minus n, x squared, nothing on the denominator, nothing at all. However, this is my coefficient here. So my coefficient of x is equal to n, and my coefficient of x squared is equal to 2n squared minus n in a bracket. Okay? The next thing I'm going to do now is read the question again. It says the coefficient of x squared, so this is 2n squared minus n, that thing there, is twice, so that's equal to 2 times the coefficient of x. So that is just n, so 2 times n. I'm now going to expand that to get 2n squared minus 2n is equal to 2n. Now you need to be very careful when you're trying to solve anything like this. Do not divide through by n here. We know if we get an n squared or an x squared or whatever, if we get a quadratic, you get 2 solutions. So this answer will have 2 solutions. Group everything onto one side, we get 2n squared minus 4n is equal to 0. The next thing I'm going to do is I'm going to divide everything by 2 to get n squared minus 2n equals 0. And then finally, I'm going to factorise to get n minus 2 is equal to 0. So I get 2 solutions here. N is equal to 0 or n is equal to 2. And if I go back and read the question, it says, given that n is greater than 0, it must be that one there. It must be 2. Okay? Over the page, this one here, again, we're focusing on the ones where we need to use the formula booklet in this video. I know I'm going to use the formula booklet because, again, I don't know the power here. Okay, so it says the coefficient of x squared is 5 times the coefficient of x. Now, let's check. Can I use the formula that I like to use? Yes, because it's 1 and then 1 there. X and then x over 4 there. Okay, but it's not x, so I'm going to have to say let x equal x over 4. So it's very important that I actually sub this into the question. Just pausing for a second, I think I've made a mistake in the last question now. If we go back, where's it? It's over the page, yeah, I just realised the mistake I've made. This isn't true by here, okay? I've said let x equal 2x, So this should have been n brackets 2x there. Okay, that means that I'm going to have made a mistake further on. So the coefficient of x here would have actually been 2nx. So this should have been 2n by here. That would have made this 4n by here. That would have made this minus 6n. And that would have made this minus 3. So that would have been equal to 3. So n would have actually been equal to 3 there. Pause the video, try and get your head around that. I'll go through the next question, and if it doesn't make any sense, I'll go through it in the lesson, okay? But sorry about that mistake, it wasn't there on purpose, I just realised now. Okay then, so this time here, I'm letting x equal x over 4, and I'm not going to make that mistake I've just realised I did in the last question. So, it says the coefficient of x squared and the coefficient of x. Now I'm going to try and use this one here that I prefer. So the coefficient of x here is generated by doing nx. So in this case, for my thing of 1 plus x over 4 to the n, the coefficient of x, so I'm going to say coef of x, would be equal to nx, but remember, I'm making x equal x over 4, so it's going to be n x over 4. So that would give me nx over 4, so my coefficient is just this bit here, this n over 4. For the coefficient of x squared, I'm going to have, so I'm checking by here. This is how I'm going to generate it, using that term there. I'm going to have n bracket n minus 1 all over 1 times 2. So that's 1 times 2, not 1.2, I don't like that notation. Over x over 4 squared. Okay, so we've got to be careful with that. That's why I've made sure I'm writing it like this nice and clearly. That's going to give me n bracket n minus 1. I could expand that if I wanted to, but I don't think it's actually going to help me in any way, shape or form, so I'm just leaving it for now. I'm going to get x squared up on the top. 1 times 2 is 2, but then 4 squared is 16, so it's going to be 2 times 16, which is going to put that over 32. So that is my coefficient of the x squared here. Okay? Now, reading the question, it says the coefficient of the x squared, so that is n brackets n minus 1 over 32. I'm getting rid of the x squared now because I'm only interested in the coefficient, is equal to, is 5 times the coefficient of x. So I'm going to say 5 brackets, the coefficient of x was n over 4. Okay? So now I'm going to try and solve this equation. So I'm going to get n squared minus n on the top over 32 is equal to 5n over 4. I'm now going to cross multiply. I'm going to bring that 4 over here and that 32 over here, and they're going to become times by. So I'm going to get 4n squared minus 4n is equal to 32 times 5. Well, 20 times 5 is 100. That leaves 12 times 5, which is 60, so that would be 160n. I'm now going to bring everything over to one side. I'll probably, at the same time, maybe not at the same time actually, I'm going to cancel it down first to n squared minus n, so dividing through by 4, and then 40n there. And then I'm going to bring that through to get n squared minus 41n is equal to 0. And then n bracket n minus 41 is equal to 0. So I have two solutions here, n equals 0 or n equals positive 41. Reading the question, it says n is a positive integer, so that means my answer is n is equal to 41. Okay then, now we're starting to come to the unseen questions. So these are taken from an Edexcel paper. It says, find the first 4 terms of the binomial expansion in ascending powers of x of 1 plus x over 4 to the power of 8. Okay? Now, I haven't put in the formula booklet on this bit because it's given me the power. I don't need to go and use any of the formula here. But you could do, if you didn't like the power of 8 and you didn't want to go to the 8th row of Pascal's triangle. I know the 5th row off the top of my head, so I'm just going to jump straight to that. And then I'm going to generate the 6th row. Now I could probably stop there because I'm only interested, oh you can't see what I'm doing, can you? I could probably stop there because I'm only interested in the first 4 terms, so I'm actually going to stop there, I'm not going to write all of it. So then the 7th row would be 1, 7, 21, 35, and now I'm going to start the 8th row. So 1, 8, 28, 56. I'm stopping there because I'm only interested in the first 4 terms. So when I start to expand out for part A, I'm going to do my coefficients, so it's going to be 1 plus 8, and then I'm really take my space on this because otherwise I'll probably mess it up, plus 28, and then plus 56. So I'm generating those from that there. And now I'm going to start putting in the numbers. Now, 1 to the power of 8, 1 to the power of 7, 1 to the power of 6, all of these are going to be 1, so I'm not even going to bother writing that in. This would be x over 4 to the power of 0, and that'll go to 1, so I'm going to leave it as that. This would be x over 4 to the power of 1, this would be x over 4 to the power of 2, and this would be x over 4 to the power of 3. So when I do expand that now, I get 1 plus x over 4, so that's 4 to the power of 1, which is 4. 8 divided by 4 is 2, so 1 plus 2x. This would then be 4 squared is 16, so it's going to give me plus 28x over 16. Okay, now I'm going to have to simplify that, but don't try and rush too quick. Maybe I should have taken my time with that one as well, but 4 into 8 twice is pretty easy to spot. 16 into 28 is not. And then finally, it's going to be 56x cubed over, now it's 4 cubed, which is 64. And I'm going to say plus dot 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 because that does continue, but they only want the first 4 terms. 1, 2, 3, 4. That's my first 4 terms. Okay then, so I've got 1 plus 2x plus half that is 14, half that is 8, half of 14 is 7, half of 8 is 4, so I make that 7x squared over 4. Biggest number I can spot that goes into both those is 8. How many 8s go into 56 is 7. 8 into 64 is 8. So that is 7x cubed over 8 plus dot dot dot. So I've done the first bit, I've got the first 4 marks. Okay then, to get the next marks, it says, use your expansion to estimate the value of 1.025 to the power of 8. Now, if I'm using that expansion, these two things have got to be linked. Okay, now I can see quite clearly here, look, the one bit, they're both there. So I'm going to cross out both of those. So that means what's left, my x over 4 here to be added on, must be equal to that 0.25 there. So 0.025, sorry, is coming in there. So then I'm going to times both sides by 4. So x must have been times that, so let's double it, 0.05, and then double that would be 0.1. So in the expansion that I've just done, wherever I see x, I want to change that into being 0.1. So I'm going to say, part B, let x equal 0.1. And then I'm going to substitute in 0.1 into each of these bits here. So I'm going to get 1 plus 2 brackets 0.1 plus 7 brackets 0.1 squared over 4 plus 7 over, sorry, not 7 over anything yet, 0.1 cubed over 8. Okay, now it's going to be very important that I take my time expanding this. Very easy to get things wrong. If I get it wrong, then I'll lose all the marks. 2 times 0.1, easy enough, it's just 0.2. 0.1 squared, now that would actually be 0.01, okay? 0.01 times by 7 would be 0.07, so I'm going to write that now, 0.07, but I'm going to leave that over 4. I'm not going to expand that quite yet. And then plus, and then 0.01 cubed would actually be 0.001, okay? 0.001 times by 7 would be 0.007 over 8. Okay then, finally, these two bits are easy enough. Divide that by 4. If you need to, do the bus stop, but I'm thinking that 0.08 divided by 4 would be 0.02. So in this case then, this must be 0.0175. But this one here, I'm not really sure, to be honest, so I'm going to do the bus stop by the side. So I'm going to do 8 and then long bus stop 0.007. How many times does 8 go into 0? 0.00. How many times does 8 go into 7? Still none. So I'm going to put in a 0 there and that becomes a remainder of 7. 8 into 70 goes in 8 times, remainder 6. 8 goes into 60 times, 7 times, remainder 4. And into 40 it goes in 5 times. So my answer is 0.0, make sure that looks more like a decimal, 0.003 noughts and then 875. Now in order to work that out, I can't answer it like that looking at it. I'm going to write it in column addition and maybe cut one corner here. I know 1 plus 0.2 would be 1.2. But then my 0.0175, I'm writing like that, and then 0.0000875 in like that. So add these together, I'm going to get 5, 7, 13, 8, 1, 2, then 1 point. And then if I'm to round that to 4 decimal places, it would equal 1.2184 to 4 decimal places. Okay, so we have seen ones like that in WJEC. Hopefully that was a good one to go through and really test yourself against. And finally, let's look at this last one here. Okay then, so first of all, it says find the first 3 terms of this in ascending powers of x. Now, I cannot use this form here because it's not in the form 1 plus x. I could maybe use Pascal's triangle, but I can tell you now I'm not liking this 3 and this bx. So I'm actually going to use this one for a change. Okay, so in terms of what I have here, I'm just trying to match up to here. So my first term, a, I'm going to let a equal 3. My b term, I'm going to let b equal bx. And then my n is going to be equal to 5. Okay, so I'm just using this one here. Right then, so if I have 3 plus b to the x, or bx to the power of 5, that is going to equal, so I'm constantly trying to catch that thing up and looking at that. It says a to the power of 5, or a to the power of n. So n is 5, a is 3, so that's going to be 3 to the power of 5. It then says this weird bracket, which I'm just going to write in. It says n, which my n is 5, n1. So 5, 1 like that. And then it says a to the n minus 1. So my a is 3, so that's going to be 3. n minus 1, 5 minus 1 would be 4. So we know the powers descend, so that's 3 to the power of 4. And then it's going to be bx to the power of 1. Okay, so bx, then in that case the power of 1 is just bx. And then it only wants the first 3 terms, so I need to do one more. So it's then going to be plus 5, 2, and then it's going to be 3 cubed, and then it's going to be bx squared. Okay, so now I've got that. I'm going to say plus dot 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 to show it goes on. So I don't really need to look too much at that, but maybe I do to work out what the brackets mean. Okay, so first bit, 3 to the power of 5. 3 to the power of 5 goes to 243, and then plus, right, this 5, 1, what does it mean? Well, if I come back and check, it says 5, 1, so nr is n factorial over r factorial, and then you just take away the 2 numbers, that top number, take away the bottom number factorial. So that is going to be 5 factorial over 1 factorial, and then 5 take away 1 is 4 factorial. So 1 plus 4 make the 5. That's how I always remember it, that whatever these are, they're the difference between the 2 numbers. Okay, so then the next one is going to be times by 3 to the power of 4, which is 81, and then times by bx. Okay, I'll worry about sorting that out in a moment. And then finally, 5, 2, pause the video and have a go, see if you can get there before me, it'll only take you a second, would be 5 factorial, 2 factorial, 3 factorial. Okay, times that by 3 cubed would be times by 27, and then times by bx all squared would be times by b squared x squared. Okay, right then, let's start getting a bit further with this then. So it's going to equal 243, we like that, there's nothing to do there. 5 factorial means, so that should be plus, sorry, means 5 times 4 times 3 times 2 times 1 over 1 times, and then 4 factorial means 4 times 3 times 2 times 1. They cancel, leave me with just 5 over 1, which is just 5. Times that by 81, and then times that by bx. Okay then, so in terms of that bit, that's going to be 5. 5 times 81, I obviously have no idea. But 81 times 10 is 810. 5 is half of 10, so half 810 would be 405 bx. Okay? Plus, that's what that's going to go to. Plus, now 5 factorial we already know is 5 times 4 times 3 times 2 times 1 over 2 factorial, which would be 2 times 1, and then 3 factorial, so times by 3 times 2 times 1. I'm going to cancel the 3 times 2 times 1. 2 goes into 4 twice, leaving that as just 5 times 2, which is 10. And then I'm timesing that by 27 and times it by b squared x squared. So that's going to go to 10 times by 27, which is 270 b squared. So plus 270 b squared x squared. So that's what that neatens down to, believe it or not. But obviously it takes a bit of a time to get through. You know, these are hard, that's why I'm doing a mini help video on it. Okay then. So we've got the 4 marks here now. It says give each term in its simplest form. We've done that. Yes, happy days. It says given that in this expansion the coefficient of x squared is twice the coefficient of x. So the coefficient of x squared, this thing here, just the 270b squared, 270b squared is, so that means equals, twice the coefficient of 405bx, or just b because I'm only interested in the coefficients. So that is going to give me 270b squared is equal to 810b. That's going to be 270b squared minus 810b is equal to 0. And then factorising that, I know 27 goes into 81 because of the powers of 3. It goes 3 cubed is 27 and 3 cubed, sorry, 3 to the power of 4 is 81. So I'm going to take 270 out of that as a factor and a b. And that's going to give me b minus 3. 3 times that would have then taken up to 81 or 810. And then my answers are b equals 0 or b equals 3. Okay, why am I double underlining b? We're told that b is a non-constant, non-zero constant, so that means it must be my answer. Okay, I hope that was useful.